Right, we're going to look at this today, straight line graphs. Reason we're looking at this was from this question in the Year 10 exam, where less than just over 50% of the students got this question wrong. So we're going to be looking at Year 10 exam question here. And what I'm going to do with all of these questions is look at a tricky exam problem. This is the tricky exam problem. You can download the OneNote notebooks and have a go at these beforehand and see if you can do them. It's a great way to test whether your knowledge on these questions. But what we will do is first of all start off with all the basics and go through the basic skills we need to be able to do this problem. It's all about straight line graphs and looking at things which are at right angles to each other. So let's start off with a gradient of a line and just check we all understand how to find the gradient of a line between the points -1 and 2 and 3 and 0. We're going to use the formula gradient equals the change in y over the change of x. I'm going to just give you a few seconds to just get your teeth into that and then I'll go through it. Right, don't worry if you don't manage to finish the questions in the times I give you. Okay, it's just so you can get your teeth into and have some understanding of what I'm doing and understand where you're going wrong or right, as the case may be. So here we go. Let's do the gradient is going to be equal to the change in y over the change in x. Now the change in y, the y value here is 2 and the y value here is 0. So if we go from the first one to the last one, the change in y will be 2 minus 0. And we're going from the first point to the second point, the change in x will be -1 minus 3. Okay, be careful with signs. We've got a -1 here and we're going to take away 3 there. So that would give us 2 over -4, which can be simplified to give us -1/2. Okay, let's another 30 seconds and have a go at the next one. Okay, let's look at that one. So we do the same again. The gradient will equal the change in y, which is in this case also going to be 2 minus 0, over the change in x, which is now 4 minus -2. So we get 2 over 6, because minus minus is plus. So that can be simplified to third. Let's just quickly have a go at doing one where you're actually given the line. I'll give you 30 seconds on that, and then we'll move on from here to look at equations of lines. Right, do appreciate there's a little bit of a lag in the stream, so if you do put in questions into the chat, it will take me about 20 to 30 seconds before I will notice I'll be able to respond to them for you, because your stream is lagging about 20 to 30 seconds behind me. So again, let's look at the change in y and the change in x in this question. So here's our change in y, which is 2, and our change in x from here to here, which is 1. We go that way, it's 1, and we go that way, it's 2, it's positive. So therefore the gradient will equal 2 over 1, which is equal to 2. Right, let's jump up forwards and look at equations of lines. Now what I'm going to do is just going to do this question, and I'll also do one where there's a graph one. Anyway, this is the most familiar version of the equation of a line that you get to look at. I would recommend you start using this version. It's much more powerful, gets the answer quicker, and allows you to just be a bit speedier in what you are doing. Okay, so let's just have a go at using this one to do this question. The first thing we need to find is the gradient. And the gradient here is going to be equal to the change in y, which is 2 minus 0, over the change in x, 1 minus 3. Be careful here. Notice I started with these starting points and I've got these finishing points. So therefore I've got my starting points here and my finishing point here. I'm doing the taking away. So I'm going to get 2 over minus 2, which equals minus 1. And then we know that AB is a point on the line. So we could choose either 1, 2 or 3 noughts. I'm going to choose, if you've got a nought in there, it makes the calculations easier. Just for argument's sake, I'm going to though choose 1, 2. So I'm going to make A equal to 1 and B equal to 2. A is the y value, x value, and B is the y value. So put that into here. Okay, into here. So we get y minus 2, because b is 2, equals the gradient minus 1 times x minus the a value, 1. So we get y minus 2, let's multiply out the brackets, minus x plus 1, and then add the 2 to both sides, y equals minus x plus 3. If the question doesn't ask you to simplify, this would be a perfectly good answer because it is the equation of a line. You don't need to go any further if you don't want to, if your algebra you feel is a bit suspect. Okay, let's move on to the next one. Have a look at the equation of this line. I'm going to give you 30 seconds head start on this to have a go, see how you get on, and then I will start working through the answer. Right, so if you realise when actually you got the intercept on the y value at y-axis, it's much easier to use this version to find the equation of the line, and I understand that. So I'll just quickly go through that. We know the gradient, change in x is 1, change in y is 2, so therefore m will equal 2 over 1, which is equal to 2, so y will equal 2x plus something, and the something is where it crosses the y-axis, which is 2. Let's also test our version of the formula y minus b equals mx minus a. So therefore we've got the same m value. We can just choose any point on the line. It doesn't have to be this point. Let's just choose another point. We could choose that point, the point 0. Right, wrong way around. So the point minus 1, 0. So our a value is minus 1 and our y value is b value is 0. So y minus 0 equals m2x. A is equal to minus 1 minus minus 1, and you get that. Y minus 0 is just y. 2, let's just add, make that into an add because minus and minus is plus, which gives us 2x 2. And you can see both methods give you the same answer. Right, let's just now work out things. Also, for other things you need to be able to do with straight line graphs, you need to know where they cross the axes. So all graphs cross the y-axis where the x value is 0. So you put 0 in wherever the x value is here. And they also cross the x-axis where the y value equals 0. So to find out where it crosses the x-axis, make the y value here 0, and then you can find the x value. I'll just give you 30 seconds to have a go at the first one, and then I'll go through it. Right, have a look at this then. So we're going to look at where it crosses the y-axis where x equals 0. So let's make x equals 0. So that implies that y will equal 2 times 0 minus 1. So y equals minus 1. So it crosses the y-axis at minus 1. And we can find out where it crosses the x-axis. We get y equals 0. If y equals 0, we know this implies that 0 is equal to 2x minus 1. Rearrange that to get 1 equals 2x, adding 1 to both sides. And then we can divide by 2, get a half. So therefore it crosses the y-axis at minus 1 and crosses the x-axis at a half. Okay, we're just going to move on from here because that's quite straightforward. Just got to put those numbers in. You can practice the other questions. I'll put the answers in later. Let's look at perpendicular lines because this tends to be the bit where things start to get confusing. So two lines are perpendicular, then their gradients multiply to get minus 1. Find the equation of the line perpendicular to y equals 2x minus 1. Okay, now there's going to be lots of lines that are perpendicular to this, so there's going to be lots of possible answers. Have a quick go at that, then I'll go through it. I just noticed a little error in here. I'll type that. Let me. Leave that for. There we go. Right, let's get on to this question. So we're trying to find if two lines are perpendicular, get that. Find the equation line perpendicular to this. So we know that the gradient is equal to 2. So we know that 2 times something must equal minus 1. So therefore our something, or the gradient, I'm just going to replace that with gradient. Gradient we want, let's call it m. That's the equation letter we're used to in the equation. So 2 times m must equal minus 1. So we divide by 2, we get m equals minus a half. Now, therefore, remember the equation of a line must be y equals mx plus c. And for it to be perpendicular, we know it's going to be y equals minus a half x plus c. Now, the c doesn't affect the direction of the line. It's the gradient, this bit, that affects the direction of the line. So therefore, any value of c will work here. So to just find an equation that's perpendicular to this one, we can put in any number we like for c. So let's just put in 5. Okay, since I got rid of my x in there, I'm going to write this equation out. It's y equals minus 2x1. See if you can find an equation of a line that's perpendicular to that one there. I'll give you just 30 seconds. It shouldn't take very long if you understood what I just went through. Okay, so we know that minus 2 is the gradient of this line here. And we know that times the gradient of the line we're looking for must equal minus 1. Therefore, m will equal minus 1 over minus 2. And minus divided by minus gives us a plus. So therefore, the m value will equal a half. So the equation of our line will be y equals a half x plus something. And it can be anything we like. Let's go for 4 this time. Or you can even have a minus value. You could have minus 3, minus 2, whatever you like there. And that will also give you an equation of a perpendicular line to this value. Now what we're going to do is we're going to now extend this even further to a slightly more complicated problem. First of all, we're going to find the gradient of this line, which is going to involve some rearranging. And then you're going to use the form where you actually have to find the equation of a line through a point. So the formula, equation of a line that we did back here, this one here, you've got to use that. So it might be worth just copying that down quickly before you attempt this next question. So y minus b equals mx minus a, where the point AB is on the line. Go down back to that question. Okay, you've got to find the gradient of this line, then find the gradient of the perpendicular line, and then find the equation of the line using the formula. I'm going to give you a couple minutes to have a go at that. I'll start the timer when you get down to the last 30 seconds. Okay, here we go. So first thing we need to do is we need to write this in the form y equals mx plus c, because we need to find out the gradient, and we can only find that out. Another way we can find out the gradient actually is to put a point in for x, find a y value, put another point in for x, find a y value, and find the gradient between the 2 points. But it should be much easier to actually rearrange the equation in the form y equals mx plus c, and then Nova m is the gradient. So let's add 2x to both sides. So we get 3y equals 2x 5. And then we divide by 3. So we get y equals, divide each term by 3. So divide that term by 3 is y. Divide this term by 3 is 2/3 x. Divide this term by 3 gives you 5. So we know that the gradient is 2/3. So we therefore 2/3 times our new gradient must equal -1. So therefore we divide by 2/3 is the same as timesing by 3/2. So our new gradient is going to be -3/2. Now we're going to use the version of the formula y minus a equals mx minus b. Some of you may have seen in textbooks y minus y1 equals mx minus x1. I avoid that for low ability students because the ones tend to upset them. They tend to get confused a lot by having two y's and two x's. But it's actually easier to help you remember that you always take the y value away from the y and the x value away from the x. So we know it goes through the point 1, 2. And the x value is 1 and the y value is 2. So we take away the y value from y. Put the gradient in, -3/2. Take away the x value, 1, away from x. And you get that as your equation of the line. And that, if this was an exam question, would be a perfectly good answer. It just says find the equation of a line that's perpendicular to the following, go to the point 1, 2. And we've done that. But let's just simplify it anyway. And I always reckon if you've got a fraction here, the best thing to do is get rid of the fraction first. So we times by 2. So timesing the y by 2, we get 2y. Timesing the -2 by 2, we get -4. Gives me -3, because now times by 2, x minus 1. Multiply out the brackets. -3x plus 3. I can get all my x's. If I bring my x's onto this side, that makes them positive. I get 2y plus 3x equals, add the 4 to the other side, 7. And that's a much neater version of the equation. And both of these would be perfectly good answers for this question because it doesn't ask you to simplify or write in any form. Therefore, if your algebra is a bit shaky, you could stop right at this here. Just before we go on to do the tricky problem, let's have a look at one other thing you need to be able to do, which is find midpoints. Now, the midpoint can be found by working out the average of the x values and the average of the y values. What do I mean by that? Well, here's a point, 2, 3, and -4, 5. So the average of the x values, or technically we should say the mean, but you can use average, that's okay. We get to find that, we add the 2 points together. The x value is 2, this x value is -4, and then divide by 2 because there's 2 of them. The 2 plus -4 is -2. Divide by 2 is -1. And the average of the y values is equal to 3 plus 5. Divide by 2, so that's 8 divided by 2, which is 4. So our midpoint is going to be -1, 4. Okay, I'll give you 30 seconds just to find the first midpoint here. Okay, let's stop that there. So the midpoint here is going to be the x values. So for the x, we're going to get 1 plus 3/2, which is equal to 2. And for the y, we get 2 plus 0 over 2, which is 1. So the midpoint is 2, 1. And there's another one for you to practice later. I'll put the answers up later. Right, let's finish off. Let's have a go at this tricky problem, which my class has done before. So have a go at this problem. I'm going to give you about 4 minutes. Have a go at this problem and see where you get to. I'll put the timer on when we get down to the last 30 seconds. Right, that should have given you plenty of time to have a look at least start the question and get some ideas of whether you're going right or wrong. Now, the key things in this question are A, E, B are on the points line L with this equation. AD are points on the line M. We know that ABCD is a rectangle. That tells us that they're going to be at right angles to each other. They're perpendicular lines. And we know that AE equals EB. So this distance here is equal to this distance here. So the first thing we can easily find the gradient of this line M here. Okay, because it's perpendicular to this one, and we can find the gradient of that line quite straightforward. But to find the equation of the line M, we need to know a point on the line. At the moment, we don't know a point. The only one we've got a chance of finding is this one at A. Because we know this distance here, EB, is the same as AE, we can then find A, because we can find the point B, because it's where it crosses the x-axis. We can find the point E, because it's where it crosses the y-axis. So therefore, line L crosses x-axis when y equals 0, remember? So if y equals 0, we've got x plus 2 times 0, 12. So x equals 12. So we now know this point is 12. And it crosses the y-axis when x equals 0. So we've got 0 plus 2y equals 12. So y equals 6. So we now know this is 6. Now we know that this distance here is the same. These two distances are equal. Now, therefore, if that angle doesn't change, that triangle there must be the same as this triangle here. So the x distance we're moving along is going to be the same, and the y distance is going to be the same up. So therefore, we can see we're going to go a further 12 this way and a further 6 that way to get to our point A. So therefore, A will be at the point minus 12, comma, 6 plus 6 is 12. 12. So we know that the point A is minus 12, 12. So we've now got our point the line goes through. Let's find the gradient of M by finding the gradient of L. So for the gradient of L, what we need to do is rearrange. We know we've got x plus 2y equals 12. We need to get it into the form y equals mx plus c, and then that will give us our gradient of L. Okay, that's how we're going to do it. So 2y will equal minus x plus 12. We take away x from both sides. You might want to write it as 12 minus x. I'm just putting the minus x at the beginning to make it more like this. Then divide each term by 2. So divide the 2y by 2, you get just y. And we're going to divide the minus x by 2, so that's going to give us minus a half x. You have minus 1x divided by 2, that gives you minus a half x plus 6. So we now know that the gradient of L equals minus a half. Therefore, minus a half times m, the gradient, our new gradient of m, is going to equal to minus 1. So m will equal minus 1 divided by minus half, or turn the fraction upside down and multiply by it. Minus 1 times minus 2 over 1, which will equal 2. So we now know that our gradient is 2. So for the equation of m, we know we've got a point on the line and we've got the gradient. Okay, that's what we need for that equation of m. And we're going to use y minus b equals m x minus a. Our a is our x value here, and our b is our y value here. So we get y minus 12, and our m is 2. minus, there's a minus 12 here. Okay, and that's an equation for line M. We could just leave it like that. I'm just going to scroll down to give myself a bit more space. So let's just simplify this just for good practice. If you're not in an exam, always try to simplify. It doesn't matter if you get questions wrong when you're not in exam. That's a plus 12. The 2 times plus 12 is going to be plus 24. Minus and minus gives me a plus. Then I can take away, add on another 12 here because we've got minus 12 there. Add on 12 to that. Add on 12 to this, we get 6. And that's our final answer. For those of you in my set, we'll start the Zoom lesson at 11:45. We've got microphone stuff. You can ask any questions about what we've done in this lesson. Otherwise, we'll go through some of the other exam. Okay, so start the Zoom lesson at 11:45. Sorry, 11:45 in just under 5-10 minutes.